3, 5. March 5th. I just wish the weather would act like March 5th. Okay, y equals x squared. So these can be done. They really can be done on the calculator. Now, before we do it, I kind of know the graph looks a little bit like, I know it's a parabola. We did this yesterday. So as I talk you through it, one of the things we want to talk about is first, on the graphics calculator, is the window. Okay, so turn it on and go to the window. So my window is what we call a standard window. Negative 10 to 10. Scales by 1. Negative 10 to 10 on the y, scales by 1. That's the standard window. That's a good window to use. So if you don't have that window, change it to that particular window. Okay, negative 10 to 10. Because that puts us right in the middle of the graph. Okay, let me show you. Just watch. Let me show you something different. Okay, I just changed my windows. Please don't change yours. This would be a really bad window for this particular graph.
Good gravy.
We would never see it. Does that make sense?
Yeah.
Because this window would put us, you know, way up here, right? You'd never see this probably. You guys agree? So the window is important that you put a window that will work, okay? So oftentimes I'll look at my graph and say, well, I could actually modify this window slightly. And I could go, you ready? Negative 5. Whoops, hold on, clear the whole thing. I could go, come on, back up. Oh, it needs something. Okay, I could go negative 5 to 5. Why not? Why not? And my graph is really like a negative 5 to a 5, right? Why not change it to what my graph looks like, right? And I could change this one, scales by 1s. I am going 1, 2, 3, 4. That's what my scales mean, okay? And I could go for my y's. I could go negative 2 to 1, 2, 3, 4, 5, 6, 7, 8, 9 to 9, right? I could, if I wanted to change it. However, the negative 10 to 10, negative 10 to 10 always works for what we're doing, okay? So now go to y equals, and let's put in x variable. X variable, you guys see x variable? X variable is right here. X variable is right by the green alpha at x variable squared. Okay? Okay, now when I graph it, there it is. And we knew it was going to look like that, right? Now, that'll work. For me, personally, it's faster to do without a calculator, but I don't mind showing you the calculator. But for me, it's faster to do without the calculator. Watch how fast it is for me. 0 squared is 0. 1 squared is 1. 2 squared is 1, 2, 3, 4. 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And I know it's symmetrical, right? So I get the points on the other side of the line of symmetry. And there it is. So the technology can get me that graph, right? However, for me personally, it's a lot faster just to do without the technology, okay? Domain, what's the domain of this? You guys remember? What's the domain? X equals all real numbers. And what's my range? Y is greater than or equal to 0. Y is greater than or equal to 0. Everybody good on that? Okay. All right. Easy. And I've got a line of symmetry, which I'm going to put in, which goes right through the middle. Okay, this is my line of symmetry. Okay, good. Thumbs up. Pretty easy, right? Okay, now, number 2. We could graph this. Y equals. I can go clear. I can go 0.5 x squared, right? We could do it on the calculator. We really could, right? Graph it. Now the hard part about the calculator here is trying to get those exact values, right? But we could go to a table and get the t-table, right? Let's see, where's the table on this thing? You guys remember? List. Is it on list? Nope, I don't want that one. Where's my table? Anybody know where the table is?
What do you mean? What? The y, isn't it y equals?
Yeah, the y equals...
What are you trying to get to?
Oh, there's a
Question
table.
3.
Oh, there it is. Table. There it is. Okay. So here's your t-table. I want to show you this, okay? So sometimes you can get all the values from a t-table, right? Remember how we did this yesterday? So where'd I go? Clear. Let me show you again. I went to right up here in blue, see table, second table, and there's my element points. I've got a 0, 0, I've got a 1.5, I've got a 2, 2. See this? Let me show it again?
Yeah.
Okay, one more time. Okay, quit. So you got to put the equation in. Have you put the equation in? Y equals?
Yep.
Everybody got that? Now, right up here in blue, see the table in blue? So I got to push blue.
Blue.
Yeah, I got to push the blue button, okay?
Oh, I see it.
See the blue word table?
Yeah, Yep.
So I'm going to go second table, and it gives me a t-table of all the points. So I have a point at 0, 0, right? This is pretty handy. So I got a point at 0, 0. So if I were to graph this, okay, watch how I'm going to do this. Okay. So I'm going to have a point at 0, 0. I'll have a point at 1.5. I'll have a point at 2, 2. I'll have a point at 3, 4.5. I'll have a point at 4, 8. 4, 5, 6, 7, 8. And it also has the negatives in there. Look at that, negative 1.5. I don't know if you guys can see it. There you can see it. It's got a value at negative 2, 2, negative 3, 4.5, and negative 4, 8. So there's lots of ways that we can do this, okay? Lots of ways. I'm trying to give you different methods so that you can always get this right, okay? So let me go back through, okay? You could graph it. Y equals and graph it. Boom, you can get it. The problem with the graph is it's hard to get the individual points. You guys see that? You could go to the table and get all the individual points, right? And just do a dot to dot. Or you could be a mathematical genius. Watch. 1 squared. What's 1 squared? What's 1 squared?
1.
Take half of that.
Half.
Okay. 2 squared. What's 2 squared?
4.
Take half of that.
2.
3 squared. What's 3 squared?
9.
Take half of that. 4.5. 4 squared.
16.
Take half of that. 8. You see how this is how I do it because it's faster for me and I know it's symmetrical, right? So for me personally, it's so much easier to do a t-table in my brain because we're smart. We can do a t-table in our brain. Okay, now let's look at number 3. Okay, so 2 ways to do it. Y equals, right? Clear. Number 3, I can go at 2x squared, right? Let's graph it. All right, there it is. Now the hard part again about my graph is to get the individual points. It's kind of difficult, right? To get those. I mean, I got the shape, but to get the individual points, so I could go to my table and get my individual points, right? So there's my individual points. I've got a 0, 0. I got a 1, 2. I got a 2, 8, right? I got a 3, 18. And I even have the negative. See how I'm doing this? Or being that we're mathematical geniuses, watch. Okay, gotta listen. Okay, I want you to listen. Okay, we're smart. So check it out. 0, 0, right? So, are you listening? Go over 1. What is 1 squared?
1.
Twice as tall. Goes to 2. I'll do it again. 1 squared is 1. Twice as tall. Okay, 2. It's 2 squared.
4.
Twice as tall. 1, 2, 3, 4, 5, 6, 7, 8. See how I do this? See how easy this is? I'll go over 3. What's 3 squared? Twice as tall. 18 is off my paper, right? But I also know I have points on the other side because it's symmetrical. Okay, how am I doing? Okay, number 4. We can do it on our calculator. We really can. I know what it looks like. So for me, I'm going to show the calculator, but I'm going to convince you. By the time I'm done, I'm going to convince you, Jacob, that it's so, and Derek, that I'm going to convince you guys that it's so much easier to do it without a calculator. Really, I'm going to do my best. So I go y equals, clear, negative x squared, right? I already know a few things about it. I already know it's upside down. I already know it's upside down. How do I know that?
Because negative.
Good. So if I graph it, I'm probably going to fix my window, aren't I? You guys agree? So I'm going to have to fix my window and go more negative on the y, right? More negative on the y. Okay. I need to go down further, so I change my y. Okay. And then, there we go. Now, but I don't have the individual points, right? I just have a shape. So to get the individual points, I could do one of two things. One, I could go to my table and get my individual points. So 0, 0, 1, -1, 2, -4, 3, -9. Or I can do the t-table in my head because I'm smart, and so are you. So I know it's upside down, so I'll put my x-axis way up here, right? Now watch, okay? Watch, watch, watch. We can do this in our brains. 0, 0. Then over 1. What's 1 squared? But then it's upside down, right? It's upside down. Over 2 is 2 squared. But it's upside down. 1, 2, 3, 4. Just a second, R2. 3 squared is, but it's upside down. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know it's symmetrical, right? Boom. All right. Have I convinced you to do it my way yet?
No.
It's so much easier and faster, isn't it? R2, question.
So, the negative symbol means it's upside down.
Right. So the negative symbol, think about this. All of my x values become negative.
So it's
So the y, all of these answers are y answers. All of these answers are y answers. So my y values become negative. It's going to go like that. It's going to be upside down. Totally right. Okay, what about 5? What about 5? Now let's think about 5. Let's think about 5. Okay, Derek said just bring it down. Take the original graph and bring it down to -4. So we're going to start at -4. So, all right, let's do that. Now you could put it on the calculator, which I'm not going to. I'm going to take Derek's suggestion. Derek said take the original. Take the parent function. 1, 2, 3, 4. Now, please, everybody, eyes up here. Please, all eyes up here, okay? Same process. From my vertex, same process. If I go over 1 from the vertex, what's 1 squared? So I'm going to put a point right there because I went over 1, up 1. Go back to your vertex. 1, 2. It's 2 squared. I'm going to go up. 1, 2, 3, 4. Okay. Go back to your vertex. Go over 1, 2, 3. What's 3 squared? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can fold it over, right? It's faster to do it this way, right, Jacob?
Yes.
There you go. What do you think? Now, worst case, you have no clue what I'm doing, right? All right. You just go y equals, clear, x squared, subtract 4, and there it is. And same thing if you want the individual points, which we could do in our head, by the way. You can go to the table and get the individual points, right? There they are. Right, okay. All right. What is the range of graph number 5?
Shouldn't be y is greater than
-4, yes. I knew you meant that. Y is greater than or equal to -4. That's the range. Reach for your range, right? So the lowest spot is -4, and then it goes up. Domain's all real numbers still, right? Of course it is. Okay, sound good? Okay, ready to turn the page? Yeah,
Would
can we?
domain still be all real numbers?
Always, yeah. We're going to change that someday, for not yet, okay?
I don't want to change it.
When we start to do square roots, we'll talk about why we have changed. You can't do the square root of a negative number, right?
Yeah.
All right, what do you think about 6? Any ideas? Okay.
Just move it up 5, but have the same graph.
Okay, move it up 5. Everybody agree with Cameron? We're going to move up 5. But what about this negative here? Max?
It's upside down.
Yes. Everybody here? So it's going to look like, watch my finger. It's going to look like this, but start up at 5. Does that make sense? It's going to be start at 5, but upside down. Totally agree, Max. So let's go ahead and put in my XY axis. Okay. And so my vertex is up here at 1, 2, 3, 4, 5, right? And now watch again. Here I am. I go over 1. What's 1 squared? What's 1 squared? Make it upside down. Go over 2, it's 2 squared. Make it upside down. 1, 2, 3, 4. Go over 3, what's 3 squared? What's 3 squared?
9.
Make it upside down. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know it's symmetrical, so we fold the points over here, okay? Boom, 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 and there it is. Again, if you have no clue what I'm doing, worst case, graph it, right? Y equals clear. A negative x squared plus 5. There it is. Okay, now if you need the individual points, you can go to your table, and you get all your individual points, okay? Not bad. So we've got really 3 ways to do it. My way, using your superior brain, is faster than the calculator. Would you guys agree with that? Okay, now what about 7?
Don't you just go over to the right?
Yes. Yes, let's check it out. Cameron is totally correct. Let's check it out, okay? Clear. If I go parentheses x subtract 2 squared, okay? Put that in your calculator. X, guys see it? Graph. We went the opposite way, didn't we? You guys remember that? Remember how you go the opposite? So this parabola is going to be at 2, 0 is where this vertex is. So the vertex, just like Cameron said, it's the opposite. Cameron said to the right, because it's the opposite of a minus 2. So let's do it. All right, so I'm going to go ahead and put in my graph.
But it's still y equals x squared.
Yeah. It's still an x squared graph, isn't it? Still is an x squared graph. So it's still a parabola. It's still our normal, standard parent function parabola. We just take it and we move it over here, okay? So if the vertex is right here, okay? Let's do it my way. Seriously, let's do it my way. It's faster. I'm right here. If I go over 1, what's 1 squared?
1.
There you go. If I go over 2, what's 2 squared? 1, 2, 3, 4, right? If I go over 3, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, where's our line of symmetry? It changed. We moved it. Yep. Line of symmetry is right here. So when we fold the points over, we fold them over the line of symmetry, right? Okay, does this make sense? So we take these lines, fold them over this line of symmetry. So I'll have a point here, I'll have a point here, and I'll have a point here. Easy squeezy, I hope. Okay, how about 8?
Guys on the left.
We're going to move it to the left. 3, totally agree. Left, 3. So my vertex is going to be at negative 3, 0. And it's going to be our normal parent function just moved back 3. I'll say it again. It's going to be our normal parabola just moved back 3. Okay, so, and you can put it in your calculator if you don't believe me, but it is true. Clear. If I go my parentheses, x plus 3 quantity squared, graph, there it is. It's been moved back 3. Yep. Yeah, Cameron?
So I have a question. So how does the subtraction one move to the right and the addition one move to the left? When on a number line, when we add, we move to the right, and on subtraction, we move to the left.
I'm glad you guys are finally asking this. For all these months, you just believe me. You just believe me. I say it's the opposite. You're like, okay, if he says the opposite, right? Why? Okay, Cameron, it's so easy. Honestly, especially with this graph. What is the lowest point on this graph? Just and then on this graph, what x value? Think about this. What x value would make this 0?
Negative 2.
Positive 2. So the opposite number zeroes it out. Think about this. What would zero this out? What x value would zero this out?
Negative 3.
That's why it's the opposite, because it gets you the very lowest point. Thank you for asking that question. Nobody ever asks. They're like, okay, if he says so, it's good enough for me, right? But there is really a good reason. It's that, what is the x value that zeroes it out? It's got to be the opposite x value, right? All right, thank you, Cameron. Nobody asks me these kind of questions anymore. They just take the fact that whatever Mr. Davis says is the gospel truth, which is true, by the way, okay? That's right. Okay, so my vertex is right here at -3, 0. Okay, let's do our 1, 1, our 2, 4, let's do our 3, 9 from here, okay? Over 1, 1 squared is 1. 2, 2 squared, what's 2 squared? 1, 2, 3, 4. Over 3, what's 3 squared? 1, 2, 3, 4, 5, 6, 7, 8, 9. It has a line of symmetry going through at -3, right? You guys agree with that? So, there we go. And there we go. Awesome. Okay, how about 9? Tell me about 9.
You have to add 3, so it's going to be plus 3 on the y, but you're going to have to
So let's go up 3 and let's go up 3 and what? We're going to go left 4. So we're going to go left 4 because we're going to do the opposite and up 3, okay? So let's take our normal graph and let's put it okay, I'm going to take my graph and I'm going to put my vertex at -4, 3, okay? Put your vertex. So start with the vertex. Your vertex has got to be at -4, 3, okay? There it is. There's my vertex, okay? Now, let's do our 1 squared from our vertex, 2 squared, and 3 squared from my vertex. So, over 1, 1 squared is 1. Boom. Go from the vertex. Over 2, 2 squared is 1, 2, 3, 4. Boom. From my vertex, 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Line of symmetry. Right? Line of symmetry. Fold the points over. And there it is. Okay, range. What is the range of this graph? Perfect. Starts at a height of 3. You guys see that? Height of 3 goes up, right? That's my range. Okay, reach for your range. Okay, last but not least, first of all, where is the vertex? Let's make this easy. Where's the vertex? +3, -4. +3, -4. Opposite, right? -4. So let's put that in. Let's go 3, -4 is where my vertex is. Right, get my XY.
Wait, what about the 0.5 though?
You are ahead of me. I'm going to answer that in just a second. It is going to affect the graph. Yep. Totally right. Okay. Okay. So, opposite, right? Opposite. So there's my vertex. It does affect the graph because this graph is going to be half as tall. Half as tall. 1, 1, it's 1, 1/2. 2, 4, it's 2, 2. Half as tall. 3, 9, it's 3, 4.5. Half as tall, okay? So, I'm going to go over 1. 1 squared is 1, but I'm not going to go up to 1. I'm going to go half as tall to 1/2. I go over 2. 2 squared is 4, right? 4, but I'm not going to go to 4. What's half of 4? 2. 1, 2. Go over 3. What's 3 squared? 9. But I'm not going to go 9. I'm going half as tall. 4.5. 1, 2, 3, 4.5. Now, we could do 4 and 8, couldn't we? We go 4 squared is 16. Half of that is 8, right? So I go 1, 2, 3, 4, 5, 6, 7, 8. Line of symmetry, where is it? Right at x equals 3. So the line of symmetry is where it's x equals 3. Line of symmetry always goes through the vertex, right? Fold the points over. Boom. Boom. Boom and boom. Okay. Okay, what's my range?
Y greater than -4.
Perfect. Yes. Okay. Let's take a look at our journal. Let's see what our journal says.